All right, this is Advanced Math, Unit 7, morning review, getting ready for our test next week. In triangle ABC, B is 12, C is 8, the measure of angle A is 37, find the length of A. And I've done this with you guys before. I like drawing the pictures only because I'm visual and it helps me to quickly figure out which formula I'm using, if I have to worry about obtuse angles, and so forth. 37 degrees for A, 12 for B, and 8 for C. Can anybody look at this without doing any work, just look at the picture or the given information and figure out which formula we're going to use, law of sines or law of cosines? Yes. Can you tell me how you know that? Because we have two sides and a sandwich angle. And when that happens, do we use law of cosines? Yeah. Do you agree we couldn't use law of sines because I don't know this side or those angles? All right. What's the first thing? Let me write down what we have first. 12, 8, and angle A is 37. What are they asking me to find? Now, according to the information, can A be the first thing that I find? If I have these two sides and I already know angle A, can A be the first thing that I find? Yes. Sometimes it's not, and you have to find multiple things first, or it's the last thing you find. Lucky for us, it's the first thing we're able to find, and so we don't have to go through and find these. All right. I'm looking for A. What does my formula start with? Hold on. 2BC and cosine of A. Does everyone agree with her? Okay. Is this the rearrange or not the rearrange?
Not really.
Who can tell me why?
Because A squared is what we're trying to figure out.
A squared is what A is what we're looking for, not the angle A. So can we just go ahead and plug in? Yep. I'll let you guys go ahead and do that now. 3 decimal places. Don't forget to either square root at the beginning or square root at the end. It's up to you. All right, what do we have? Three decimal places, 7 point.
393.
Would it be 393?
Yeah.
Let's check. Okay, that's okay. So 7.393. Do we all agree? All right, so that was for A, 7.393. Now, because it didn't say solve the triangle, it just said find the measure of side A. Are we done? Yes, this is it. That's all I have to find. I don't have to find angles B or C. Right? Okay. Questions on number 1. Could you handle something like that on your own? Yes.
How do you know when to rearrange?
Good question. Can anyone answer that for him? He asked, how do you know when it's a problem you have to rearrange? Yes.
You're looking for the angle?
When it's the angle that you're looking for. When the angle's the first thing you're looking for, or the whatever time in the problem you're looking for it, if it's the angle you're looking for, it's the unknown, you move everything over. I had like 2 other hands up. Were you guys going to say the same thing?
Yeah.
Okay, good. Number 2. In triangle ABC, B is 12, A is 22, and the measure of angle A is 42. So I have 2 sides and 1 angle like the last one. Let's see if it ends up looking the same. A, B, C. A is 42. B is 12, and A is 22. Is it another one where there's two sides and the angle is sandwiched? Yes or no? No, it is not. Okay, so can anybody look and tell me whether you think we're going to use law of sines or law of cosines? Okay, can anybody explain how you know it's law of sines? Is that what you guys said? Yes.
Do a side and angle, like corresponding.
A corresponding side and angle. And I'm looking for something else, and I have this side, which means I can find other things. Yes? Okay, what did they ask us to find? Side C. They gave us angle A is 42, little b is 12, and A is 22, and they're asking us for side C. Now, on this one, can C be the first thing I find? No, earlier I was lucky. This one has multiple steps because in order to find side C, what do I need to find first? Angle C, and in order to find angle C, I need to first find, so do I need to find everything? Okay. Can anybody tell me what I need to do before I start going through and solving? No one remembers? Looking for possibly obtuse angles. Okay, am I using law of sines? Yes. So I have to check if there's possibly an obtuse angle. Now, kids often ask, well, how do I know which one's possibly obtuse? Well, if I'm using law of sines, it's going to be the first angle I'm looking for. Is this the first angle I'm looking for? Yes, that's the first angle I'm able to find. They're not asking me for angle B, they're asking me for side C, but is this the angle, the first angle I'm going to find? Yes. So when I look here, what's opposite angle B? And what's bigger, 12 or 22? If 22 is bigger than 12, which angle's bigger, 42 or angle B? 42 is greater than angle B? If 42 is bigger than angle B, is there any way that angle B is obtuse? No, there's no way it's bigger than 90. So do I have to worry about case 1 and case 2? Is this the problem that we learned quite some time ago that we can just use law of sines and everything's fine and dandy? Yes. All right. So you guys said angle B first. So what would I have? I'm going to have one of you guys give me the equation. Read off what the equation would be that I'm going to write down. Anyone? Sine of?
42 over 22 equals sine B over 12.
And because this is not law of cosines, I don't have to rewrite it. I am looking for an angle, but I don't have to I mean, I do have to cross multiply, but I don't have to do like what I would have done over here by subtracting and dividing. All right, so go ahead and cross multiply and divide. Second sign, second answer at the end. Three decimal places. Anybody have it?
21.406.
21.406 degrees. If you're not getting these numbers when you plug it in, now is the time to stop me and say, Mrs. Torres, can you help? Or ask your neighbor, because I can't help you on test day on how to use your calculator. All right. Sophia, can you tell me what I would do next?
After you found the answer to the angle,
Mm-hmm.
then you would have to find, I guess, you add 42 degrees plus angle B, and then you subtract that number from 180.
Do you guys agree with her?
Mm-hmm.
Good job. She said you add 42 and 21.406 and then subtract those two from 180 to get angle C. Beautiful. Thank you. All right. Anybody has done it?
116.594.
594. Now, can I finally use law of sines to find side C?
Yep.
Now, I'll have kids say, oh, but Mrs. Torres, that's an obtuse angle. Is it okay to use law of sines on an obtuse angle? I just can't use it to find an obtuse angle. I'm not looking for an angle, I'm looking for a side. Catherine, can you give me the equation you would use to find side C?
Sine of 42 over 22 equals sine of 116.594.
Thank you. Is this an inverse key problem? No, because I'm not looking for an angle, I'm looking for a side. Go ahead and plug it in your calculator. And I do want to talk about this one because on the quiz, I had a few of you guys round incorrectly. Not sure if it was this class or just my morning class or both. So I'm just going to go over it really quick. How do you round when you have those nines there like that? 3 decimal places. It's 399. And is that 9 going to change the next number? So just think of it as 399. And if you were to round that one up, what would you get? So it's 29.400. And yes, you put the zeros in. 29.400. I had a few kids put 29.399. I gave you credit on the quiz. I will not give you credit on the test. Okay, questions. Now, am I done with the problem? Is that all I need to do? Just one case? Why is there only one case? Because angle B was not possibly obtuse. Do you guys agree? Not obtuse. We know for sure because it's smaller than 42 degrees, so there's no way it's bigger than 90. Okay. Yes?
Do you only do 2 cases on a sine problem, or do you do it on cosine?
You never have to do it on law of cosines, just law of sines. Because law of cosines, you are allowed to use it to find an obtuse angle, so you don't have to worry about the 2 cases.
When you're doing,
Are you
when you're trying to find a case, is it always, does it matter, like, does it, you only have to find angle B that's greater than?
Yes.
Or does it, can it be C or A?
It could be technically any angle, but for us, it's always been angle B. Like after you check that angle, do you have to check any others? No. Just check the first one that you're looking for, which for us will always be angle B. After you check it, you don't have to check the others. Okay. All right, let's draw a picture. A, B, C. A is 20.5. B is 31. And A is 12. Okay. Could I, if I wanted to, use law of cosines on this one? No. I have an opposite, I have a corresponding angle inside. I can find that angle and go forward. What do they ask me to find? So, let's write down what we have. A is 20.5. B is 31, or A is 12 and B is 31. Okay, so we look at this problem, and because we're going to be using law of sines, and I'm looking for side C, which means I need to find what first? But in order to find angle C, I need to first find, so what's the first angle, or what's the first thing, period, that I'm looking for here? So if I'm looking for angle B, do I have to check if angle B is possibly obtuse? Yes. Okay, what's opposite angle B? And the only other set I know is A and side A, and that's 12. What's bigger, the 12 or the 31? So what angle's bigger, angle B or the 20.5? Angle B is greater than 20.5. What does that mean? Could it be obtuse? Which is why we say it's possibly obtuse. It may not, but it possibly could be. So angle B is possibly obtuse. Now, if it's possibly obtuse, what does that mean about our work? How many cases do we have? 2. I'm going to do case 1 first. Now, what do we know about case 1? What's nice about case 1? You do it like you've always done it. So angle B, there's no way angle B is obtuse. Angle B is not obtuse. So what that means here is there's not a unique one solution. There's going to be 2 solutions. One where angle B is not obtuse, and there'll be another solution where angle B is obtuse. All right, so do here the same thing you did up on number 2. Find angle B, then find angle C, and then find side C. Go ahead and do that now. I'm going to move my paper off screen to let you guys do it on your own, and then we'll check and see. Do I have to use inverse key when I'm looking for angle B?
Yes.
Okay, go ahead and do that now. All right, what do you guys have?
64.783.
64.783. Now I put that in like a little pencil bubble, but is that technically the final answer that I'm looking for? No, this over here, which is going to be the last thing I find. Now, Sophia told us earlier, so I'm going to call on Max. Can you tell us what I do next? And how do you find angle C? Perfect. So he said 180 minus the 64.783 minus the 20.5. Have you done it already? 94.717. Thank you. All right. Now again, case 1, B is not obtuse, and you can see right here 64.783 is not an obtuse angle. All right. Go ahead and use your information now to find side C. Anyone have it? 30, 34 what? 149. Okay. On the test, if you did all this beautiful work and you stopped here, would you get it wrong?
Yes.
Yes. Why? Because there's 2 possible solutions. All right. So now I'm going to do case 2. Before I get to case 2, anyone have any questions on case 1? Would you, what was that?
Angle B that's unknown.
Angle B is obtuse. What do you mean?
Like on this one, like we don't know angle B, and that's the way it's been on like all of our notes. And
Yeah, that was the question Hunter asked earlier. For us in this class, it's always going to be angle B.
Okay.
But technically in the real world, it could be any of the angles.
Okay, that's what I thought. So I was just
Yeah, just making sure. Yeah, it's always going to be angle B that we're looking for first that's possibly obtuse. But when you get to higher level math classes, it could be any of them.
Okay.
But once you check it the first time, you don't have to check the second angle or the third angle. Okay. Who remembers what we do? What do we start off with? How do I know what information to use in the beginning? Okay, even before that, what do I fill in?
You're given.
Can I use the original given information? Yes. All of that will stay the same. Bless you. 12, 31, 20.5. Now, Jacob, you were saying something. I heard you about subtracting. What was that?
You subtract angle B.
Okay. Now, we just said we cannot use law of sine to find an obtuse angle. So if B is obtuse, should I use law of sines to find it? No, it's not going to work. So he said, take the 64.783 and subtract it from 180. So 180 minus. Go ahead and do that now. And what do you guys get? 0.217. Now, is angle B obtuse? Yes. Did we say it should be obtuse? Yes. Is it okay that it's obtuse? Yeah, it should be. Did I use law of sines to find that angle? No, I didn't. I subtracted this angle up here. Okay. Now, yes.
What if it's like not obtuse? You just do right here.
This one here.
Yeah.
Oh, if this one here will never, when you're doing the 2 cases, the first one's never going to be obtuse. But once you do 180 minus an acute angle, it'll always come out to be obtuse. All right? Okay. Anybody find angle C yet? Do we all agree? Okay. Alec, can you give me the equation to find side C? Sine of 20.5. Okay, keep going. You did say it right.
44.77.
We're down here.
Oh. Oh, 44.2 degrees.
Uh-huh. Over C. So go ahead and plug that in now. Anybody have it?
23.92.
I'm sorry. Again, 23.924.
924.
Okay. On the test, when you have your answer column, what would you put? Just one of these or both of these? You'd put both. You'd put 34.149, comma, 23.924. Does that make sense? That's your answer here, the two sides. That means there are two possible ways to draw a triangle with those three pieces of information. You can draw it with those three pieces of information and these three that we found in pencil. You can also draw it with those original three and then these three. Both of these would make a triangle and everything would be fine and dandy. So those are your two, those are your two answers. Questions on this, not obtuse, possibly obtuse, and how to work it out? No questions? All right, do we have to worry about this stuff when we're using law of cosines? No. Okay, number 4. Given triangle ABC, A is 15, B is 25, and the measure of angle A is 85. Find all possible lengths for side C. A is 15, B is 25, and angle A is 85. Law of sines or law of cosines? Law of sines. Now, let me fill in my information and figure out, I'm looking for side C, and let's figure out what it is I have to find first. All right. Grace McCoy, can you tell the class, according to this information here, what do we have to find first if I'm looking for side C? Angle B. Does everyone agree? And then use that to find angle C, and then that to find side C. What do we have to look? Since I'm looking for an angle first and I'm using law of sines, if B is possibly obtuse, what's opposite the B? 25. What's opposite the 85? Which one's bigger? 25 is bigger, so angle B is bigger. Do we agree? So it's possibly obtuse. All right. Angle B. Who can give me the formula that we're going to use? Anna? No? Anissa? Can you give me the equation?
Sine of 85 divided by 15 equals sine of B over 25.
All right, go ahead and plug it in. Is this an inverse key problem?
Yes.
Now, I've not been showing you guys how to solve it. You guys know how to cross multiply and divide it, yes? Okay. Good job. All right, do you guys get it? Did you get domain error?
Yes.
Yes. What does domain error mean? No solution, not a triangle. Triangle does not exist. If you put domain error, I'd rather you just put no solution. What that means is that, like, say this 15 side here, or one of the sides, this 15 is not big enough. Like, you have this piece here, but the angle's too big, and this side is too small. It's never going to meet up at an angle. Does that make sense? Or it could be that angle up there, most likely, because that's the one we're looking for first. Okay, make sense? Okay, no solution. Now, you don't have a lot of these on the test. There's like one. So if you keep getting domain error, should you keep putting no solution? No, you're making a mistake. Go back and check. All right, questions before I move on to 5. Okay. True or false? Blah, 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 blah. Anyone, any guesses? Is this the way our formula usually looks? No, what does it usually look like? I'm going to start with the sign C. If I have sine of C, what must be at the bottom? And if I have sine of A, what should be at the bottom? A. Now, these little guys are in the wrong spot, so I'm going to divide both of them on both sides to see if I could get it to look like this. So what I'm going to do is divide both sides by AB. Can you guys see that dividing by AB will reduce the A here and reduce the B there? Does everyone see why I'm doing that? Because I don't want them there. I want them in the denominator where they should be. A is gone, B is gone. What does that give me? Sine of C over B equals sine of A over A. Now we did our work correctly. Is that true or false? False. What's wrong? That B, little b should be a C, or the big C should be a big B. Yes.
On the test, you have to do that work. Can you just say false because there's a B in it?
Good question. She said on the test, do you have to do all the work, or can you just say false because there's a B in it and we know there shouldn't be a B? I struggle saying just, yeah, you should know, because on the work, this one here, this was from the review that you guys, that I gave out on block day. Does this one here have extra letters? There's sine A, there's little a, there's sine C, there's little c, and there's B's in there. Does it have extra letters? Should that B be in there? No. Does that mean it's false? Oh, see, that one's not. That one comes out to be true. So if you can see that the B's are going to cancel out, that's fine, but you want to be careful and not just automatically say true or false, because sometimes there's work involved. All right. All right. This one, I'm going to look at my two signs. I have sine of B, not sim of B, sine of B, and I have a sine of C. What little letters go at the bottom? B and C. Okay. Anybody tell me what I can do? Can I cross multiply to get everything like that sine out of the bottom? Or multiply both sides by sine C? Would that work out the same? Does everyone understand that sine C should not be in the denominator? Sine C to the top, sine C to the top, and then divide your little letters as we did in the last problem. Hello, Mrs. Torres. Yes. Uh-huh. Bye-bye. Okay. Little c sine C equals the sine C reduced here, and I have little b sine B. Like the last one, what am I going to divide both sides by? Little c and little b. Does something reduce on each side? The c's are gone, the b's are gone, leaving me with sine of C over B and sine of B over, that should be an uppercase B, sorry, sine of B over true or false. This is what it should look like. This is what I have. This is what I was trying to get earlier. So this is false. Does everybody see that? All right. I'll have you guys try the next one. Yes.
So, how do you know like what you're supposed to divide by, and like how you start?
Like where to even start? Okay, here's what I see. That was a really good question. Okay, so first thing I look at is my uppercase, my angles, sine B, sine C, and then I rewrite the formula with that. Did I write it down correctly? Okay, so that I figured this is what I'm looking for. Now, do either one of these have sine in the denominator?
Yes.
This are the signs at the top.
Oh, yes.
This is what I'm looking for. So this one has it in the denominator, which I don't want it there. So that's the first thing I take care of, is getting it to the top. That's it. Just getting rid of it in the denominator. That's the first thing you should do. And the only thing I did was put the little c in the front. C and then sine C equals B sine B. And then I still look at what I'm trying to get. Where should the lowercase letters be? In the top with the sign or in the denominator? So when you divide, you have to divide by both of them. One is B, one is C. So you divide by BC. So the B's would reduce here and the C's would reduce there.
Letters have to go together.
Yes. Yes. Okay. All right. Did anybody get the other one? True or false? True. Can you guys tell me what you did? Divide by BC, because that's really the only thing that's not in the right spot. Now, I didn't write down what we're looking for only because this one was a little easier. The B's reduce where? Here. The C's reduce here, leaving me with sine B over what? Sine B over B and sine C over C. And is that the way it should be? So that is a true statement. All right. Find side A in the right triangle given angle B is 50 degrees. And C is 8. The office called you. All right. Because it is a right triangle, what am I able to do? I can find all my angles. What's this top angle? 40. All right. What am I allowed to use here? Did you have a pass?
Just taking pictures. Soccer.
Okay. The morning reviews are over there somewhere. All right. Because it's a right angle, what am I allowed to use that I could not use on all, like these triangles up here? I heard Pythagorean's theorem. I can use what?
Oh, never mind. I think it's.
I heard you say sine.
Yeah, but.
You can, but specifically the SOHCAHTOA. Could you use SOHCAHTOA on the other ones? On non-right triangles? No, you can use law of sines and law of cosines, but you can't use like opposite over hypotenuse. If we wanted to, could we use that here? Okay, I'm going to show you the two different ways I have kids do it most often. This was the original angle given. I know the hypotenuse is 8, and what side did they ask me for? A. So this is the side they're asking me for here, yes? Okay. I don't need B, so I'm just going to cross it out so it doesn't confuse me. What is 8 in reference to the right triangle? Or reference to this, actually. Opposite, adjacent, or hypotenuse? Okay, that's always going to be the hypotenuse. What is the A? Opposite or adjacent? SOHCAHTOA, which one's adjacent over hypotenuse? Which one? Cosine of 40 or cosine of 50? 50, because this is the angle I was sitting at when I said adjacent hypotenuse. Cosine of 50 equals adjacent, we don't know, we could call it A, over hypotenuse, which is 8. Is that pretty easy to do? Multiply the 8 to the other side, and that right there is what you plug in your calculator. 8 times cosine 50. Go ahead and plug that in your calculator now. 8 times cosine of 50, and tell me what you guys have. 142. Okay. Did anybody work ahead of me and do it a different way? Yes.
But I didn't
I did sign.
I didn't get
Okay.
5.
You did a different way, but you didn't get that answer. How about you two?
Yeah.
You did it? Can you tell me what method you used?
I tried doing the law of sines.
Uh-huh.
So I did sine of 90 degrees over 8.
I'm sorry, let me fix that. Okay. Sine of 90 degrees over 8. Let me do that really quick. Okay.
And then equals sine of 40 over a.
Sine of 40 over a.
And then I cross multiplied.
A times sine of 90 equals 8 times sine of 40. And then what did you divide both sides by?
90.
Sine of 90.
I thought I wasn't allowed to do. But you can divide by sine of 90?
Because you can't like reduce signs out, but you can reduce the whole sine of 90. Yes, you can divide by sine of 90 because sine of 90 is just a number in your calculator.
Oh, okay. Because I tried to divide by sine on a different problem, and I couldn't do it because I was like trying to find the angle. But this one, since there is an angle, you can divide it.
Yes.
Okay.
When you're trying to find an angle, you end up dividing like by a number like 12 or 13. It ends up being a little different. Okay, so plug it in. Does it work? Those of you that tried it, can you plug it in now? Yep. On the test, does it matter which method you choose? No. How many of you feel like you would most likely do it SOHCAHTOA way? How many of you feel like I've done this so much, I'm most likely going to pick that way? Totally up to you. When I make my answer keys, I have both methods worked out so I can check your work. And remember, I do check your work. Okay, next one. Oh, really quick. So this one did also come out to 5.142. All right, number 7. The measure of angle C is 85, A is 45, and little a is 420. Find B. If a picture helps, draw the picture. If you don't need the picture, it's not necessary. A, B, C. Angle C is 85 degrees, obviously not drawn to scale. A is 45 degrees. A is 420. Find B. Now a picture would definitely help on this one because does it look like I could possibly use law of sines because I have this set right here? Now if I'm using law of sines and I'm looking for side B, what do I need to know first? And I don't have angle B, so why am I still allowed to use this method? Good, we have these two angles that we subtract from 180. Can you guys do that now? Does it come out to be 50? Does everyone agree with her? Okay, it was 50 given to us. Do we need to know to find that?
Yes.
All right, so I'm going to set up the equation, check the answers, and see if we have to do any rewriting. What would it be? Sine of 45 over 420. Do I need to worry about anything being obtuse if I'm looking for a side? No, I don't have to worry about checking. Okay, do they have an answer that looks like this? No, because there's an equal sign here. They're asking you pretty much what would you plug in the calculator. So what do? I'm trying to get what by itself? B. So they're asking you again here, what would you plug in the calculator? So when I multiply, B times sine of 45 equals, what is that, 420? Times sine of 50. And the question was asked, can you divide by sine earlier? Yes. What would we divide both sides by? Sine of 45. Do you agree this right here is what you would get ready to plug in your calculator? Should you plug it in? No, check to see which one here matches this. Which one is it? Is it this one? 420, sine 50, divide by sine 45. D is the answer. Any questions? No questions? All right, are you guys doing the next page? No, we're going to do that together next week in class.